starts out with 3x squared subtract 3x over x squared plus x subtract 12. Okay, that one we're going to do. Is there one with a 2x squared subtract 5x plus 2 over x squared subtract 4? And I've chosen those from the handout then. So we need to look at those. Oh boy, hang on. Is there one x squared subtract x subtract 12 over x plus 1? Those are the ones I want to look at. Now, don't get frustrated. My goodness, these rational functions can drive you nuts. Thank goodness polynomial functions are doable. We'll use that word again. When we try those, these rational functions can get away from you. So I've got to be very, 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 very careful. Now, let me show you what's going to happen. Then we'll have a student read for us as to how we should approach these. Guys, on these rational functions, I'm going to start out with the one I just listed. We'll sketch. And we'll start out with R of x, R of a rational. Then we'll start out with this one. Get some input from you. Like this. Over this. I will have that copied down correctly. Okay. Now, if I were a student, just beginning maybe a calc course, and I saw this, I would think first, is there a graph or something that looks like that? I might be able to simplify, Professor, with my algebra skills, factor a little bit and things and so forth and so on. I may be able to simplify this thing first. But you tell me there's a graph of it? Yeah, this thing has a graph. It has a picture of what it looks like. First though, I think this can be simplified. You guys help me. Algebraically, could I take out a common factor, see if you agree with me, of 3x in my numerator and have that? Is that okay? May I, and sometimes this happens, may I also maybe factor the denominator from algebra and factor this into maybe, help me out guys, what is it, x plus 4 and x minus 3, help me out. Are those the factors of my denominator? Now, it's coming up shortly, not on this one though. As I take a look at this and simplify it, does anything cancel out at this moment? From numerator to denominator, any canceling going on? If something does cancel out, and you saw one yesterday, I think in class, what might you expect to happen on that grid when I finally get to the grid, if that happens? Which is not going to happen here. What happens to the graph if, for an example, maybe I had gotten an x plus 4 here, and then these two would cancel. What does that indicate is going to happen? Does anyone recall? Hole. There's going to be a hole on the graph. This one does not have a hole on the graph, and nothing cancels. I'm pretty well simplified here, so I should be able to do this. Now, before I get to the grid, who would like to read for us the few steps that I need, and I'll identify a few things, and we'll put things together and get the graph. Who would like to read? Lord, no volunteers. Mr. Park? Yes, please.
Just step 1.
Yeah, step 1. Tell me what step 1 is.
Find the domain of R of x. Do not cancel factors in step 1.
Okay, he says, Professor, go back to this. You've already simplified it. And take a quick look at it. Don't cancel anything else they're telling me, which I don't have anything to cancel out to begin with on this one. And name the domain. Well, I see right quickly, x cannot be equal to, in that simplified version, -4, positive 3. Now, if you'd like to write that in interval notation, go for it. I'm happy with that. X cannot be those two numbers. So that's step 1. You get partial credit for each one of these little steps. Okay, how about step 2?
Step 2, simplify. write r of x in lowest terms.
Okay, which we've already done, so I'll just repeat what I've done here. It is dealt there in reading. You get that, I give you partial credit for that. What's number 3?
Name the intercepts x and y of the graph.
Okay, now they want to know where, before I get to the grid, where these will show up. You guys know what the function is, polynomial, rational, quadratic, whatever it looks like. To find the next intercept, you always replace y, or r of x in this case, by 0. And you have, now you do it here, or here. So let's use the simplified version. So you set this equal to 0. Now, someone suggests what's going to happen here as I attempt to find the x-intercept or solve that equation. What's going to happen? And how can I easily solve it? How can I easily solve this? Could I cross multiply? In other words, you can make this 0 is 0 over 1. You can say quickly, Professor, I can multiply these two together, which is nice, because those two multiply together is 0. Multiply these two together, it's called cross multiplication. Of course, you'll end up with this, 3x times x minus 1 is equal to 0. It's a quick cross multiplication. Then solve these, split these up, and guys, as I get one in class, can see x is equal to 0 is a possibility, and x is equal to 1 is a possibility. Let me write those on the side as nice ordered pairs. 0, 0, 1, 0. Y-intercept, a little bit easier. Find the y-intercept, go back and replace all the x's by 0. In other words, find r of 0. Now you may do it here, you may do it in the original. It looks like it might be easier in the original. Guys, if you replace all those x's by 0, please tell me, well, I end up with 0 over a negative 12, which is 0. And of course, you end up with 0, 0 for the y-intercept, which you expect because you got 0, 0 for an x-intercept. They are the same here. Look at all that partial credit. Now, nowhere near the graph yet. Number 4, what do they ask me to do next?
Step 4, determine the vertical asymptotes, if any, of the graph. Note set denominator equal to 0.
Okay, so guys, if you want to know where the vertical asymptotes are, let me just abbreviate here. He's telling me to go back and set the denominator, this, equal to 0. Where it was undefined. So take x plus 4 times x subtract 3 and set that equal to 0. Split this up and solve, and you will quickly end up with these. So those will be my locations when I get to the grid of my vertical asymptotes. Set the denominator equal to 0. Are we okay so far? Okay. What's the next step?
Determine the horizontal asymptote, if any, of the graph.
Now, hang on. I know I had something lengthy there from calculus written on your handout. Now he's asking me to find the horizontal asymptote, the horizontal line that my graph follows. Go ahead and read what I have there. This is where I'm going to give you a shortcut. How do we find the horizontal asymptote based on what I have on the handout?
It says the horizontal asymptote will describe end behavior of the function.
Okay, hang on now. So this sort of helps you to describe the end behavior, which we certainly have done something with that before on polynomial functions. But this is going to sort of describe the end behavior of this graph. But now, how do I find where is it? Because I got to place it on the grid. Tell me more.
Okay, to find the horizontal asymptote, we use the end behavior of r of x equals 1 over x.
Okay, let's do this. So if you try it right now with what it told me, find the limit as you make x get large, that means way out on the end, of 1 over x. I think I worked with 1 over x yesterday. That's what's going to happen to 1 over x, the value. as you make this down here get larger and larger and larger, like 1/2, and you jump it up to 1/100, and you jump it up to 1/1000. What's the value becoming? Smaller and smaller and smaller, and we say it's approaching
Negative.
0. Those values are approaching 0 as you make the x there, not my denominator, approach infinity. Does it make sense? That fraction becomes.
But that's only if it's proper though.
Well, yeah, it's proper. Yeah.
This one isn't proper.
What are you talking about? Give me your description of proper.
Like x to the second power over x cubed.
Hang on. You're ahead. Hang on. But right now, I'll accept this. You would accept this statement here, wouldn't you? Does it make sense? If you make x get large, 1/x gets small, it's approaching 0. Does that make sense, guys? You can try values there. Okay. Now, based on the handout, I'm saying please use this fact to find where the horizontal asymptote might be on this blue one here. Because I gotta find the location. That's what I suggested yesterday when they do in calculus. I'm gonna give you a few shortcuts. They suggest that you go back to the original, because I want to where the location for the horizontal asymptote. So this, I would go back here and try to get as many of these right here in that blue. So as soon as I get that 1/x in there, I know I can replace 1/x with 0 for the end behavior. Guys, the routine usually is check this out and find your highest degree, or your highest exponent. You say highest exponent. Guys, as you scan the numerator, the highest exponent up there is 2. Also scan the denominator, the highest exponent there is also 2. So if you find what the highest is, which is x squared in this case, the routine is go through and divide all this by x squared. It's a little lengthy, but they do this. 3x squared over x squared, subtract 3x over x squared, denominator x squared over x squared, and let's see, plus x over x squared, and then finally on the end, subtract 12. I'm squeezing it down here at the bottom, guys. 12 over x squared. So you go back here and divide through by the highest exponent you see. And then simplify those terms. Now if I simplify those terms, this is calc technique. Bring it over here. Well, my first term, the x squared right here, would drop out. They would cancel out and leave me merely have 3 placed here. My second term, subtract, the second term from algebra, I could cancel x into x squared and get an x down here. That's 3 over x. Is that true, guys? Better yet, with what I want, let's write that as 3 times 1 over x. That's still 3 over x. I'm trying to get that 1 over x in as much as possible. Denominator, well, we left out here, x squared over x squared, first term down there is 1. Second term would be 1 over x when I simplify it, x over x squared. My last term is a strange one, 12 over x squared. Can someone suggest how could I, nothing cancels there, but how could I rewrite it and try to get as many of these 1 over x's in there? Right here. What would you suggest?
Negative 12 times 1 over x times 1
Okay, yeah, by 12. 12, that's the 12 there. And then Jonathan says, Professor, go ahead and write that as 1 over x, 1 over x. That takes you right back to 12 over x squared. A little lengthy, but they do it in calculus also for another reason besides this. Okay, can you guys see all this? Yes, no? Okay. Now what am I allowed to do with that 1 over x? Based on the red, I can replace each one of those 1 over x's by 0. So that means this is 0. This is 0. This that Jonathan gave you, 0. 0. Based on this. Now what's they going to leave me for an answer? Well, see at 3 out front. Guys, 3 times times 0 here is going to drop out, which I wanted. So I got a 3 altogether in my numerator. Denominator, I got a 1 out front. And I think, guys help me out here, this drops out completely, it's one over x. And here 12 times 0 times 0, does that also drop out? So I'm left with only merely what, 3 over 1, everything else canceled out? And I know, of course, that's 3. After all that effort, you put a y here, that tells me to go up to 3 and draw my horizontal asymptote when I finally get to the grid. Now, would you like to see the shortcut of how to find that horizontal asymptote and not go through that lengthy process? Would you like to see it? But I showed the calculus technique also, because most of us, I hope all of us, are moving to a Math 7 course or a calc course somewhere, okay? What's the fast way? Here we go. This is rule number 1. Go back to the original. Check out, try to find the degree, guys, or the highest exponent. The highest exponent here is a 2. If I go down to my denominator, is the highest exponent again a 2. Do they match up here? Are they the same, I'm gonna call them degree, same degree on top and bottom? If they are, your horizontal asymptote, if this is the case, is always merely this number, coefficient, over that coefficient. 3 over 1, which all this lengthy process finally took me to. So the best case for a rational function is they match up, the degrees match up. And therefore you used to look at the coefficients and you got the answer in no time. You don't have to go through that lengthy process. Okay. Number 5, I have that done. Guy, read number 6.
Number 6, determine the oblique asymptote if any of the graph.
Now, did I write anything else besides just what else did I write?
We will be considering linear oblique asymptotes. The oblique asymptote is another way to describe the end behavior of the function.
Oh my Lord, another asymptote to worry about. Did I say anything else on that, or was that it?
There's a little more.
A little bit, tell me a little more.
The oblique asymptote exists if the degree of the numerator is 1 or more than the degree of the denominator.
Whoa. So when that finally comes up, which is going to come up today, he says, Professor, when you check these things out, the best case is these two are the same. Like my case here. But he says, Professor, if you start checking out the degree on top, you get something like this. 3x to the 4th. And down here may be x cubed. They're not the same this time. Read that last statement to me one more time, if you don't mind.
The oblique asymptote exists if the degree of the numerator is 1 more than the degree of the denominator.
Which in this case, it would be. Therefore, you're going to end up with not a horizontal asymptote. He says you're going to end up with something called an oblique. Oblique asymptote, I know a vertical line. Vertical asymptote, I know a horizontal line. Horizontal asymptote. What on earth, if this happens, it's going to happen, I think, on the last example here on your handout. What's going to happen for an asymptote? You're going to have this. You're going to have a slant. Some textbooks will call it a slant asymptote. Not vertical, not horizontal. It's at an angle. And it's going to be a line. And that's what serves as an asymptote. That's not happening on this one. Thank goodness. Was that all we have on the handout?
A little bit more.
What's the next part?
To find the oblique asymptote.
Okay, beautiful. Beautiful, I appreciate the reading. Since this one does not have one, let's hold off until we do have one. What's next? Is there anything else after that?
After that, in step 6, R of x will never have both a horizontal and an oblique asymptote.
You can't have both. You either have a horizontal or an oblique, or maybe none, but you cannot have a horizontal and oblique at the same time. That's not what happens. And one more thing.
One more, it is possible for the graph to intersect its oblique asymptote.
I think he's given me enough information for this particular problem here. I think we have enough to try to graph it and see what the shape looks like. Okay, guys? Here it goes. If I get to the grid, based on all he read for me, and I appreciate you reading for me. Let's put all this together and see what on earth does this look like. Arena, Mr. Park, you guys remember doing these?
Mm-hmm.
You do, don't you? I get this worked out the way it should. Here we go. Let's go to the grid. Start placing these things on the grid and get a graph. Let me see if I show of hands and be honest with me. I know students come with me with different experiences. Some students may have seen this before. Let me see by show of hands, who has cannot recall ever seeing one of these crazy rational functions before? Jonathan, look at those hands going up. See, 1, 2, 3. Maybe 3 hands. And some are just halfway up. They said, Professor, I think I've seen it, but I don't remember. But Jonathan's hand went way up. I've never seen this. So I gotta be careful how I approach this. Okay, guys, start putting things together here on the grid. I'm gonna go back and I'm gonna pick up the intercepts. We'll place those on the grid. And we found those, if everything is correct, we got 0, 0. I'll try to use black marker. And 1, 0. Y-intercept is also 0, 0, so that's done. So the intercepts are done. Vertical asymptote, we have 2 of those. So let's go out to a -4. Let's go ahead and mark it like this, guys. And the other is located at 3. So that will be the location of my vertical asymptotes. Now I'm gonna put those in red. Anyone tell me why might I choose red to place the vertical asymptotes? Why might I use red? Other colors here. There's an asymptote here. Guys, in fact, I'm gonna do it like this. See where it is located. And there's one out here at 3. That looks like this. I put them in red because you can't touch those. Never, 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 never touch a vertical asymptote. Why? What's the rationale behind it? Never let a graph touch a vertical asymptote. Caroline.
Well, the denominator would equal
That would
0.
make the denominator 0. She's exactly right. We can't have a denominator 0. So you never touch those. No active skies, but you can't touch them. The horizontal, you gotta be careful here. Try the blue marker will work for me. One right here, okay. We found one, it was up at 3. Gotta do this. All this straight. Let's go up to 3 and show the horizontal is up there. This. Guys, it's going across like this. And that. There's my horizontal. I got the verticals, I got the horizontal, I have the intercepts, and I'm looking back to see if I have additional information. Am I overlooking anything? Where's that it?
Shouldn't you check to see if the y equals 3 equals?
Whoa, we're not there yet. We're not there yet. Hang on to that thought. I know what you're thinking. Okay, now, if I placed on the grid right now everything we have, all the information, here we go. Here's a possibility. This graph is broken up into 3 pieces. It's discontinuous. There's something going on over here to the left of that red. I don't know what it looks like yet. We'll see. There's something going on in between the two red vertical asymptotes, and there's something going on the right. You may have to at times plot additional points to see what's going on. Does anyone have an idea? I see in between, at least we have an advantage in between. At least I have 2 points to work with. I know my graph, whatever it looks like, it's gonna pick up those 2 points. So that's the advantage of the in-between right now at this point. Does anyone have an idea of what the graph may look like? I have not plotted additional points. That's caught between those 2 vertical asymptotes, and you gotta pick up 0 and 1. Give me an idea. Who has an idea what it might look like in between? And it may take plotting additional points. Who has an idea? And I'll try. Let me ask you this. Jonathan?
Yep.
You think it may do this? I take that shape? But I have not played points. Anyone have an idea? Because there's 2 points staring at me. If I were a beginning student, say, Professor, I have no idea what you're talking about. What does that piece of the graph look like in between? It may take some additional points, but also may take my knowledge of those asymptotes.
Is it like a parabola?
Now, when you say parabola, okay, here goes. Don't try it. Don't put this on your paper yet. Or you tell me it might, and it's in blue here, it might do this. Pick up that and come through and pick up that and go back down and follow the red on this side.
Yeah.
Guys, is that reasonable? Does it follow the red? Does it pick up those 2 points? Now you say, Professor, suppose I'm not as quick as he is, and maybe I won't see that as fast. You can plot points. You go out to the side here, say, Professor, I'm stuck on this. I don't know why these markers. I'm stuck on this, so could I form a table right quickly? Of course you could. And try a few points inside, caught between, and see what happens. Let me just try one for an example. Adrian, is this what you were thinking of?
I put 1/2.
Oh, you tried 1/2 here.
Yeah, because it's in between 0 and 1. See if it was opening up or down.
Oh, this is that. So, but he tried 1/2. I was going to try something else first, but he said he's tried 1/2. And what'd you do? Did you take it back and put it in here, or what'd you do with it?
Yeah, I put it back into the equation.
Okay, and did you actually get a number, or did you just want to see what the sign was?
I just wanted to see what the sign was and it was positive.
He says he went back, put a 1/2 in here, guys, to see what the sign comes out to be, and that sign tells you whether you're going to be above or below the x-axis. And he says that might be enough, Professor. He found it to be, I guess, positive, and was above the x-axis. Clever. But I'm going to do this. I appreciate what he's done for us. I'm going to try a nice number. Let's try 2. Suppose you tried 2 here, and you actually went back and carefully placed it either here or here, and not with the value this time. So if you replace x by 2, guys, here goes. I see 6, let me mess up here, times 1, replace it by 2. Down here I see a 6, 2 plus 4, and a -1. Do we agree? Altogether, that's 6 over a -6, that's a -1. Is it? So in the table, if you want to plot a few points here, you know out 2, down 1 must be on that graph. Out 2, down 1, is that on his parabolic shaped curve there? It is. Then you could try maybe another point out here to see where it's located. Okay, that makes sense? Woo! Jonathan's asked about this. He says, Professor, could that in between, Adrian says it's going to look like that. Could it have done this? Okay, here it goes. Oh boy. The guys I'm going to come back to this. Here's a possibility.
you telling me maybe it crosses a horizontal asymptote and does something like that? John,
Can in multiple cases be on,
I mean,
can.
you're talking about something about multiplicities and all that. But do you accept what Adrian gave us, even with the help of a table there? That the graph looks something like that we had there. Adrian, I'm gonna accept this. As if your classmates will accept it. It looks like you might get an agreement here. That looks something like that. In between. Now you can plot points. Now I'm worried about the edges. Miriam? There's something going on out here. I have no clue yet. And there's something going on out here. I have nothing out here to work with. At least I had 2 points in between. I may definitely go to a table there to see what's going on there maybe. And I'm gonna try, Miriam, I'm gonna try with your help here. Let's try something out to the right of 3.
Okay.
I'm gonna try 4. If I go back and I crunch out 4, here we go guys, I'll put it here. 3 times 4 is 12. Just try numbers. 4 subtract 1 is 3. I'm trying to 4. 4 plus 4 is 8. And here's a 1, if I did that correctly. Did I do that correctly? I think it's what, 36 over 8? Is my arithmetic okay, guys? And I guess this is 4 and maybe 4 and a half? We have to divide 8 and 36, I did that quickly also, is it?
Yeah.
4 and a half? So it says, if I trust this, Miriam, out 4, if I got to here, I should be at 4 and a half. Well, my horizontal asymptote's up at 3. Is it definitely then above 3? At 4 and a half. So that tells me that this piece I'm looking at on the right is above that 3 horizontal asymptote. And I would think, let's put it like this. I should extend my vertical. Here. So that little piece in the corner, to follow the asymptotes, is going to look something like that. That's done. It takes effort. This could be an exam. One problem. I guarantee you, if I came here and just gave you one problem, some of my students would sit there for 2 hours and work on it. Yeah, because it takes a little effort. Now, there's something going on over here. Maybe the same thing was happening over on the other side. Maybe there's a piece up here. Now, we'll try something though. Guys, out to the left of -4, I'm gonna try -5. Just to see what is going on here. And we'll see what that might give me. -5. Here we go, take a -5 back. I guess 3 times a -5 is a -15. A -5 subtract 1 is a -6. Do not let me mess up here. -5 plus 4 is a -1. -5 subtract 3 is a -8. I hope I did all that correctly. It's going to be a positive answer. Positive over a positive. Oh my goodness, what is that? 15 times 6 was it? Is that 90? 90 over 8? The truth? 11 point something? So where's that tell me my last piece here? Is that 11 point something definitely above 3? Okay, so the last piece of my graph is this little piece in the corner. That looks like this. And it follows the asymptotes. Jonathan? There's the graph. You guys will accept it? Of course you will. Yeah, we could plot additional points, but I think that might be it. Check and see, guys, if you agree. Okay, that's your head nodding yes, Professor, yes. And it took a little bit of effort. Go ahead.
Okay, so I just want to double check. So we find the ones on the outsides, it just didn't, I think there wasn't any damage, but on the outsides, we find them just by plugging in the numbers still?
Yes, yes.
Okay, okay.
And also, being that the asymptotes, -4 and 3 are odd, it goes to infinity, positive and negative at each one.
You could think of it like that.
So like, being that you found the middle one, you could already just find know that they're gonna do that.
Exactly. I
And each
understand what you're
asymptote, it has to be that now, if it's even, you would have that over there possibly.
Hey, you're talking about something like multiplicity there. Yeah, absolutely, you can do that, you can do that. But I think the way we approached it makes sense. Until you have one staring at you on a quiz. Then you say, where do I start? I'll have these steps typed up for you, by the way, on the quiz or the exam. When you have one of these, you will not have one of these until later on. But I'll have the steps typed up. Will that help? Step 1, find. Step 2, find the intercept. Step 3, find the vertical asymptote. I'll have those typed up for you, and you can find each one of the parts like I did. And put it all together and have a graph, of course. That's true. Now, before I leave this, whoa, okay, let's do this. Let's see if I can. I'd like to find, based on this graph, if I can read the graph. Number 1, I'm trying to find the mark here. I'd like to find the limit as x is getting large of this function whose graph I'm staring at. Anyone tell me if x is getting large? X is approaching infinity. Translated, you're gonna grab hold of this graph, this is the graph, and you're gonna take it this way forever. That's that. That says you're approaching infinity. On the x, you're pulling it horizontally forever. What's the graph itself doing? You're pulling it to the right forever, that's what this means. What's the function value or the graph itself doing? Is it dropping closer and closer and closer down to that horizontal asymptote, which is 3. That's your limit. That's called end behavior. If you check the other end, I think, though, I'll do it. The limit as x is approaching negative infinity of this function translates into, since I have the graph, this time you're going to grab hold of the graph, the blue graph, and you're going to go this direction forever. And pull that blue graph along with you forever. What's it doing? Is it getting closer and closer and closer to the blue line up there? The blue, yeah. The blue line again, which represents 3. This is much like end behavior of the horizontal asymptote. What else should I ask? Yes, limit. Now I want a clever answer here. X is approaching 3 of this function. Why not? Now what is my graph doing as you approach 3? Well, guys, I see 3. 3 was one of the vertical asymptotes. I want to know what's happening as my graph gets close to it. No, tell me again. I got you. What happens when my graph gets close to 3? I heard one answer was what? Negative infinity? I think I heard negative infinity. Does anyone see something else that could be happening? Could it be a positive infinity? If you approach from the left, if you approach that red vertical asymptote at 3 from the left, in other words, you're coming in this direction. This is calculus altogether. You're coming in here, in that direction toward 3. What's my blue graph doing? It's dropping down through infinity, negative infinity. If I approach 3 on the other side, I just said approach 3, I didn't tell you which side. Then you're approaching 3, this time here, like that. You're staying on the right of 3. Where's my graph located to begin with to the right of 3? Is it up here? And what's it doing the closer I get to 3? Is it going up this way? The closer I get to 3? So in this case, on the other side, it's approaching what? Positive infinity. One side's approaching negative infinity. But professor, which one it is? It can't be both. It can't be both answers. I see a possibility of a negative infinity. It drops down here on this side. And on the other side, close to that red vertical, it's going positive infinity. Can't be both. What do we do in calculus? We place on this 3 a little superscript. If it's a positive superscript, not exponent here, I can squeeze this in.
like that. If I put a little superscript with a positive sign that says they want the answer to be one on the right of 3. So guys, on the right of 3, right here, is this piece here. And we said it's approaching what here? Positive infinity. That would be the answer, and there's only one answer. If though I rewrite this as limit as x is approaching 3, and I use a superscript of a negative sign, that says now, look to the left of 3. And guys, here's 3, so negative, I think we looked at this earlier. To the left, my blue graph is to the left right here, it's dropping down through negative infinity. Now the answer is this. It all depends on which side. Positive, negative, right, left. Which side will you be looking at to get the answer? Okay, so that's just something, look at the board's full. And this is only one problem. Now, can I do all this on all the remaining problems, Miriam? We'd be here until what, this is July? We'll be here until September, right at the end of September, beginning of October. Should I go ahead and reserve this room? Yeah, just go ahead and reserve the room, tell SMC, I need this room. Why, Professor? We got a little carried away with rational functions. So I need more time. So far, so good? Okay, last question. Let's see if you know how to read the graph. I'd like to find, I used R back here, I sure did. I'd like to find this. R at 2025. Professor, are you nuts? You're supposed to go back here. I know how to find R of, F of, G of. It says go back to your functions, be patient, replace all those x's by 2025, Professor, which means squared. Well, that's pretty nice to square 2025 to begin with. Times 3, 2025 here, multiplied by 3, crunch it out. That's what it means to do. Go back and replace R by 2025. That's where you find f of x or R of x. Does anyone see? We're not going to do that. It will take forever. Does someone see what the answer that I'm looking for might be for R at R of 2025? See the hand going up. Adrian.
Wouldn't it just be like 3 point some really small number?
Now, tell me. I stopped my graph on the x-axis at 3. That's where I stopped. This says no. Go all the way down here, outside this room and so forth, and down the street there, until you reach 2025. And you're going to pull that blue graph along with you as you go out this way. Now I want you to go all the way down to 2025 on the x-axis and tell me, where is that blue graph located? Where do you think it's located at? Way down there at 2025. Is it still close to this horizontal asymptote, which is 3? Is it pretty close to it? Will it ever get there? No. It's close. So I would say the approximate answer, I'm not going to actually plug that number in, it's approximately 3. So R at 2025 is approximately 3. Now, if you have the time and you enjoy doing this, go back and replace all these x's by 2025 and crunch and crunch and cry and crunch and cry and see if you finally get 3. Now, are you going to get exactly a 3? Adrian says, Professor, you're not going to get exactly 3. That's why I put the approximate symbol. He says this graph will still be above 3. Is that true, guys? So it's going to be 3 point something. Very close to 3, but 3.0000004, maybe. And the graph tells me that. Wow. Now, can I take this much time on the other problems? I can't. I can't. This one, look how much time it took me. I've got other things to do. You got other things to do. But we got that one done. Look at it closely, guys. Okay, we're going to try one more. I'll have to come back to this, but we'll try one more with you, right now, and see if we go through another process here, at least one more time. My student ready to, yeah, go ahead.
This is step 7.
Step 7, what's step 7?
It says, are there any holes on the graph?
Okay, beautiful, I wanted to indicate if there's gonna be a hole or not, and there might be one on the second problem coming up. That would be if, after I did all this business way back initially, if something had canceled. So if one of these factors had canceled out, then you would have a hole on the graph. That did not happen on this one. Sometimes it happens, you gotta show the hole on the graph. Wow, wow, wow. Okay, let me see if I'm ready. I am ready. Here we go. 2x squared subtract 5x plus 2, is that one on there? It's over x squared subtract 4? Okay. Hang on, are we ready for this? Oh boy. Now, before I leave it, yeah, I wrote myself a note here. Before I leave this, Adrian, I just forgot, we talked about this, you gave me an answer. Johnson says, sometimes, when you start pulling this out this way, and you stay close to 3, he says, Professor, is it possible that maybe, you brought this up early on, that maybe that horizontal asymptote's going this direction, might this, as you pull it along here, might it somewhere cross over the horizontal and continue, but continue like this. It still stays close to it, but for some reason it's dropped underneath. So basically it's still following that line, but sometimes it'll cross over and then follow it. The one asymptote we can't do that on is the vertical. We can never touch the vertical, the red. That could happen. Now, here we go. Adrian, you're gonna help me out here. Just thought about you. And Jonathan, does this, before I leave it, does this graph, way out here somewhere, may not be way out there, maybe short distance, might it cross over somewhere here, and still follow the horizontal, but now it's underneath it. It's underneath that 3. And it's called a crossover point if it exists. Okay, here it goes. I'm gonna check this right now before I leave it. Is there something called a crossover point? And I think my student was reading for me, mentioned something about maybe a crossover. Now, can anyone in this clever class tell me, how would you try to find, if there is one, does it cross over somewhere out there? Sometimes it doesn't. It looks like the original I had up here. But it may cross over on this one. Can anyone give me a technique that you might try to find, does the graph of this cross over, where is it? Where's my horizontal? Cross over this line. Does this and my graph of the function, do they cross over and have a crossover point? Can anyone come up with a little technique I could try to see if they do, and we'll try. Maybe they don't. Then I'll close this thing down. Give me an idea, what might you be clever to do to try to find? Does that 3 and my function have something in common? In other words, do they have a point in common? How might you find that point if it's there? Miriam?
Could you set it equal to 3?
Set 3
Set 3 equal to our function.
equal to my function. See if they have something in common. Are they equal at a certain point? Set 3, my horizontal, equal to, and I'm going to use the original, my function. And see if they have something in common. By the way, that original function was written as 3x squared. Jonathan, this is for you. Subtract 3x all over. And Adrian, this is going to be for you also. Over x squared plus x subtract 12. Look at all this. This is all the sports space, one problem. Okay, let's do a quick cross multiplication. Guys, in one direction, I see 3x squared plus 3x subtract 36. Do not let me make a mistake, it's just cross multiplication, multiplying these two together. In this direction, cross multiplication, I get 3x squared subtract 3x. I hope I do not have a mistake there somewhere. You guys agree? A little cross multiplication? Now, if I can solve that for x, we may have a crossover point here to worry about. Guys, if I try to solve that equation from across the street, these cancel out. I've got to find some green markers here shortly. These cancel out. Oh, can I solve that from middle school? I sure can. I can move that over, move this over, and I think we'll end up with 6x is equal to 36. Are you kidding? X is equal to what? 6. That tells me when I get out to 6 on my grid, I guess I'm out to 3 already. When I get out to 6, it's going to cross over. Now, how would I indicate that point at which it's crossing? Well, x is 6. Of course, the y is 3. Let's disappear. Of course, no. So out 6, up 3, there's a crossover point. So that means, here we go. Adrian, Jonathan, first for you. This is, hang on just a second here. Let me move this so we can do it. Close this one problem down. Can you imagine taking this much time for one problem here? We're going to erase all that. And move this out to 6. This is my x-axis. Okay, 4, 5, 6. And let me just make that look like that, maybe. And have my crossover point right in here. And that crossover point is 6, 3. Wow. And then it continues and follows the horizontal that's underneath it. Wow, wow, wow. Adrian. May I still keep your answer here when I say go out to 2025? I'm out to 6 now. Move on out to 2025 along that x-axis down there. Can I still say it's close to 3?
Yes.
Except this time it's what? It's beneath 3. So that means R at 2025 is close to 3, but since it's below, it drops below at this point here, crossover point, it extends this way, so by the time I reach 2025, it's definitely still below, but still close to 3.
2.9.
Like, thank you, like 2.999. If it stayed above, it'd be like what, 3.0001. This one drops below, so it's close to 3, like a 2.9999. Wow. Make sense, guys? Look at my time. One problem. Wow. One problem. Yeah. He said, Professor, how am I going to be able to do one of these? And you have a 5-page test coming up. You have a 5-page test coming up on Friday. That's what I have. And you have a rational function, Professor? I'll have to let you know. I'll have to let you know. I may have to, I haven't decided yet, I may have to save the rational function for our next quiz. Not the quiz tomorrow, our next quiz.
Oh, yeah.
I'm not talking about it tomorrow, I'll let you know, next quiz. Just so you won't have so much to worry about. Okay? Now, this is a time where I would be reaching out to my TAs, which I think some students are. They're reaching out to Arena, Mr. Park, aren't they? I guarantee you that 2 o'clock session, more than likely tomorrow, it'll be packed. If it's not, I know who's attending, who's not attending. I don't take attendance, but I know who is there with me. So guys, start coming in at 2 o'clock session. work with my two TAs, go to the math lab. That math lab is open to, I think, almost open till midnight, isn't it? Or
Mhm.
10 o'clock or something like that?
Till 10.
So call it time. You can always get help. Okay, now, this one's done. Now, I'm looking, and I might want to do one more. I can't do as much on it as I did this one. This one's a beauty. This one was a nice one to do. Had so many different parts to it. And I'll have all those parts typed up for you. So you'll see exactly what I'm asking on that, when you finally see one of these, okay? Guys, I do have, though, I think you guys said I had 4 altogether, I think. Is that true? At the bottom there? Yeah, but since I need to move on into chapter 4 here shortly, I'm already, chapter 4 is gonna be a relief. When I start chapter 4, you say, oh, thank goodness. No asymptotes to worry about in chapter 4. No crossover points to worry about in chapter 4. None of these crazy limits where you approach maybe from the left or the right. What's happening here? Not chapter 4. Guys, we close this down with this. Now this one I may move it a little faster. This one's done. Jonathan, did we answer your question?
Yes.
Okay. This guy does his homework and he's ready. Okay, last one here, guys, let's see if I can squeeze it in. Let's call this part 2, and I'm going into chapter 4. That means we'll have to come back at some time to do more on rationals. Today, we go R of X, this may be a little bit easier. R of X is equal to 2x squared, subtract 5x plus 2 over x squared subtract 4. I think you guys will tell me this is on the handout. Yeah, this is gonna be faster, thank goodness. It's a rational function. And Arena, if you guys are not taking advantage of her notes, oh my goodness. She makes my notes on the board shameful with what she presents to you guys. Have you seen all that neatness she does? How neat she is with her notes? Okay. Okay, first thing we'll do, I'm factoring. I hope it works nicely for me. Fine. Yeah, let's try to see if this works on something dark. Okay, R of X is equal to, a little bit better. I think some factoring going on here to simplify this, guys. 2x, x, minus 2, minus 1. Step back and look at it, beautiful. Denominator, difference of squares. This one's going to be much easier. Right. Now, do we have in this one, as my students tell me, do we have a factor that cancels out? If I try to simplify it. Looks like it's a factor of what? X subtract 2, if all this factoring is done correctly. Looks like it cancels out. Which immediately takes me into the simplified version as this. 2x subtract 1 over x plus 2. I guarantee you, if you're just a beginning student, you said, Professor, even at this point, this one's going to be easier to grasp. This is it. We've simplified just into that. It's still a ratio. It's going to be much easier to graph though. By the way, since this did cancel out, guys, I would take that factor that canceled and I would set it equal to 0 and solve it. And that tells me we're going to have a hole on the graph. Where? At 2. There's going to be a hole on the graph. Now, exactly where is it? Well, x is 2. That's why I set this equal to 0 and solved it. What's the y? Just go back and replace x by 2 here in your simplified version. If I do, guys, I think I end up with 3 over 4, yes or no? I did it quickly. If I put a 2 in there, is it 3 over 4? I see some looks like a professor. I don't know what's going on. I just replace x by 2 here. simplified version. I can't go back here and replace x by 2, it's undefined. Every there's gonna be a hole on the graph, and I finish this up at that point. Now let's get this one done. We'll call it quiz on rational functions for right now. Now, as I set the grid out, and to make this move just a little faster, but still realize what's going on here. Here we go. Number one, he read all this to me. Number one says, please write the domain of this function. And we'll just write the domain. Guys, in the red, x cannot be equal to, at this point, what? -2. Is that true? Look for the domain. X cannot be equal to a -2. Now though, go way back to step 1 and read the domain, how to find the domain again for me.
Find the domain of R of X, do not cancel factors in step 1.
They want you to find the domain before I did that canceling. So guys, I got definitely a -2, I can't use -2 right here. He says, but professor, they want the domain before you did the canceling. What else should I consider? X cannot be also what? 2. There are 2 numbers here. They want you to identify that domain, something's happening at that, for those domain numbers to begin with, before you cancel. Now, can anyone tell me what's happening at, do you think, we found the hole at the graph, that's what's happening at 2. Anyone tell me before I go any further what might be happening at -2? Why are those 2 not to be used? I see why 2 is not being used, because there's going to be a hole there. Anyone tell me why -2 may not be used? What do you think is going to happen when I get to the grid at -2? Go for it.
The 0 in the denominator becomes undefined.
Yeah, it's going to be undefined. Therefore, if it's undefined, what may happen on the grid?
A vertical axis.
Love it. You're going to have a vertical asymptote. Now, I'm going to go ahead and finish this up. Absolutely, she said it perfectly. Okay, domain's done. Number 2, guys, simplify this. We've already done that. R of X in simple form is that red, this. All these just a little lengthy here. 3, I think, are the intercepts. Let me do this one since we already done one earlier. X-intercept is set the, I'm going to use the simplified version. Set it equal to 0, the red. Do a quick cross multiplication, and I think you'll end up with that. You do a quick cross multiplication. Solve for x. I think x is merely 1/2. I think. I prefer an ordered pair. There you go. There's my x-intercept. Y-intercept. And you get credit for all this. Y-intercept, really go back and replace all the x's by 0. In other words, find R of 0. Guys, we're doing it in a simplified version. Replace all these x's by 0, please. I'm going to end up with a -1/2. Interesting. So my y-intercept, ordered pair, is written like that. Partial credit for all that. Number 4, I think when you read this to me, it's now time to identify the vertical asymptotes. Now, where do you think the vertical asymptote, and I'll tell you ahead of time, there's only one, where's it located? Where's that red line that I had on my other graph? Where's it located on this one? X is equal to where? Where's the location? -2. Can't be 2 because 2 is where the hole is. -2. I hear that. -2 would make a 0 denominator in my simplified version that says, hold on, you have a vertical asymptote there. And the last, then we'll graph this, where on earth is that located? And if I look back at the original, did we look out here, did the degrees match up? So in no time, not using a calc technique, is the horizontal asymptote going to be located at 2/1, those coefficients, which is 2, y is equal to 2. Jonathan?
Yep.
I'm ready to graph it, bud, this is for you. Before I leave it, might my graph cross over my horizontal asymptote as it did on that last one? And to find out, I think Miriam says, to set that two, Professor, equal to the original, and if you solve it, you have a crossover point to worry about. Guys, my original looked like this. 2x squared, subtract 5x, plus 2, over x squared subtract 4. So I'm saying this equal to my original function, to see if they have something in common. They may not have this time. Cross multiplication, 2x squared subtract 8 is equal to 2x squared subtract 5x plus 2. Okay, guys, I'm looking at it. Maybe it's just see what's going to happen here. We're trying. Checking, make sure I did all the arithmetic correctly here. The 2x squareds will cancel. We guys, is all the arithmetic done correctly? Can I do my cross multiplication? Is all it done correctly? Yes? No? Is it done correctly? Cross multiplication? Okay. If I finish it up, guys, try to solve for x, moving things around, we get 5x is equal to what? Looks like negative 5x. No, 5x equal to, is that 10? 5x is equal to 10 if I try to solve that simple equation. X is equal to what? 2. You say, oh, Professor, there's a crossover point. Well, no. Why, even though I got a 2, why do I now know, no, it's not like that last problem you had, Professor. You're not going to move out 2 and make the graph cross over that horizontal asymptote of 2 here. Why not? What's happening at 2? There's a hole on the graph. So I cannot use it as a crossover point. There's a hole on the graph at that point. Let's see what this looks like before we get all this done.
You're gonna stay with love?
Yeah, we're gonna see, absolutely. Okay, guys, here goes x-intercept, they go out to, all the there's 1, out to 1/2. Here we go. There you go and label this as 0, this is 1, and my x-intercept is right here at 1/2. Y-intercept looks like all that's correct is down here at negative 1/2. That's right here. Now get out of your way here. Those are my intercepts. I used to have those. Number 3 and number 4. Vertical asymptote, we're thinking there's one at -2, so they go out to a -2. And place the vertical. And I'll use red for the vertical. Something like this. There's the vertical place. Horizontal is supposed to be up at 2. Do that. And guys, I'll place it up here. That'll get some help from you. Something like this. Now I got the horizontal, the vertical, I think I have all my information on here. Oh, there's a whole other graph also. Out 2, up 3/4. So let's move out 2, up 3/4. And we'll plot that. Guys, out 2, up 3/4. Was that the location of the hole, if I have no mistake? Yes? So that means, I'm putting green, out 2, up 3/4 is right in here somewhere. Green will work for it. There's a hole there. That's what we're going to do today. This will wear you out. Okay. There's a grid. Barbod, I gotta put all this together. Can you tell the class, since I've taken some effort here, how many pieces are there to this graph? The last one, I'll tell you, had 3. Something out here, something in between, something down here. How many pieces are there on this one?
I think this one's 3 as well.
How many vertical asymptotes do you see?
One.
One. I think I had 2 vertical asymptotes on that last problem. That means there's only something out here to the left of the red, and something's happening on the right. There's only 2 pieces here. I see no points to work with out here. At least I do have some points here, out to the right of. Now, since I have some points to work with out there, does anyone have an idea? I could plot points like I did in the table, from a table. Does anyone have an idea of what it might look like? Cause I gotta pick up this and show it goes through there, and shows the hole there. Gotta pick up that y-intercept, and I gotta follow that red, and I gotta go up and show it's gonna follow the blue. What do you think it looks like? Any ideas? I see someone showing me there. Show me again. Okay, here we go. Try it, guys, with this. I saw this. Professor's gotta follow the red, not touch it. Go up, pick up that y-intercept, pick up that x-intercept. Come over, show there's a hole there, and then it continues forever toward or bounded by that horizontal asymptote up at 2. Picks up the intercepts, shows the hole there, follows the asymptote. Can anyone tell me what's happening on the left? They could plot points. Oh, I see. Nima, when you did that, are you telling me it's up here?
Yes, exactly.
Hang on. The professor, it's up here following those asymptotes like that. Nima. Before we accept that, I accept it right now. But some students may think, and I as a student may think, Nima, could it have done this out there? That'll do this on your paper. Could it have followed the blue and the red down here? What's wrong with placing it down here? He says place it up there. What's wrong with placing it, if it did happen, down there? Is it going to pick up another x-intercept? Did we have any other x-intercepts to work with on this problem? No. So if you place it down there, you're going to pick up an additional x-intercept. He is correct. It's above there. Go for it, yes.
On the test, do we have to show, or like, do we have to show that we plotted points to show like?
No. If
You
you
already
know what's
know.
going on, no. If you're a student who says, Professor, I don't know whether it's going to be above, below, I need to plot a few points, then yes, those students can definitely use the table. No, if you see what's happening, go for it. Guys, there's the graph. A little bit better than that first one.
Yeah.
It's true? And I'm not even finished with this. I'm finished with it for today, but I'm not even finished with graphing. I think I have 2 more down there I'm supposed to discuss. So I'm gonna hold off on those. Don't have to worry about these on the quiz tomorrow. It's not on the quiz tomorrow. My goodness. Give a little time to adjust to this. Okay, on the side here, close this down. Number 1. We've already listed the domain. That's no problem. Let me throw it out to this class. Can anyone tell me, I did not ask for it on the last one, what might be the range, since I now have the graph? And be careful. What might the range look like, the up and down, and tell me in interval notation? Is it dropping down forever? So I know to start with negative infinity.
2 3/4.
Now look at that. Johnson says, Professor, it goes up from there, that goes up to 3/4, that's where your hole is. It's not supposed to be included. So he says you've got negative infinity up to 3/4, not included. And then Jonathan, how you gonna now show, let's see, what else? Is it from there going up toward 2?
Yeah, so union, parentheses 3/4 to infinity. No,
Uh-uh.
no, not to infinity, I'm sorry, to
2.
and then parentheses.
Look at that.
Sorry. Yeah,
Is that true? The range? Am I finished or is there more? Does this piece now go forever on this side? So he's got union what now? 2 through what? Infinity. Wow. Welcome to summer 2025. Math 2 SMC. Adrian.
May I ask how you found the Y value for 2 again? Because there's a hole there.
Okay, try to find it. Right here?
Yeah.
I took that right back to my red simplified version and replaced the X by 2.
Okay, thank you.
Absolutely. Now, you're gonna get the same information if you took class at Stanford, you are, but, not this detailed. Oh, no. That professor at Stanford, don't sit there and think you're in an auditorium. When I taught at the university, when the class had 150 students in an auditorium when I was teaching there. Wow. So they do not mess around. They just go through it quickly and say goodbye. And they do it within an hour. They're done. Yes, I saw a hand going up though. I thought, yes.
Did we check if there were crossovers?
Beautiful. Beautiful. She says, Professor, we tried to cross over. We tried to, right here. And we got an answer of 2. But I couldn't accept it because we already said there's a hole at 2. That's why we cannot use it as a check. Okay, guys, one more thing here. See if we get close to the break. Thank goodness. Here we go. I'd like to find the limit as x is getting large, x is approaching infinity, of this function, since I have the graph in front of me. So it says grab the blue graph here and start going this way, pull it this way forever. How would you describe its behavior? The blue graph itself as you pull it forever to the right. What's it doing? Nima?
It's approaching to 2.
It's approaching 2. It stays underneath it, but it's approaching 2. Maybe on the other end, written like this. And since I have the graph in front of me, it says now take this, grab it, pull it this way forever. And what's my blue graph doing is I drag it this way forever toward negative infinity. Is it also getting close to 2, but it's on top? Is it still getting close to 2? Here. Nice. Number 3. I'll close this down so the break will come up. Beautiful. Find the limit as x is approaching. Now I want you to approach that negative 2 from the right of my function. Written like that. Here's negative 2. Now I want you to stay on the right of it. That's what that superscript of a positive sign says. Stay on the right. But get close to it. But stay on the right. Is this the piece of the graph that's to the right of the red, but still close to it? How would you describe what's it doing as it gets close to the red vertical asymptote? Is it dropping down through negative infinity? And the last thing here, limit. As x is approaching negative 2 from the left, like that. And guys, this time we're going to stay to the left of negative 2 over here. And the closer you get to that red, you're on the left-hand side of the red, what's it doing? What's that, is that graph doing on the left as you get close to the red? It's rising forever to positive infinity. Wow. Far by. I want you to answer class. Tell the class what this is. I got just a couple minutes. put an inequality symbol less than zero, and I want you to solve it. First thing comes to mind, you may say, Professor, we'll use sign analysis. I love sign analysis, Professor, I'll use sign analysis like we always do for inequalities. Now within seconds, far like, Mr. Mathematician. Tell me, based on your graph, what's the answer?
Below the x-axis?
Thank you. You've got to look at the piece that's below the x-axis. You don't have to go through sign analysis if you have the graph. Please tell me, I'm gonna shade it. Is this the piece right here of my blue graph, the function? Is that the piece below the x-axis? Now, when is that happening? Be careful.
Well, from -2, but it's not
It
included.
is, -2, not included.
And goes on to, is that a half?
A half.
Yeah,
And since I want it to be less than 0 and not less than or equal to,
open.
that's open also. That's exactly what I want to hear, mathematician there. There's the answer. So you could go back and do sign analysis. I see some of my students look so tired. Today's what, Tuesday or Wednesday? Oh, I can imagine how you guys are gonna look the 6th week. The last week, I'm gonna look good. The 6th week, I'm gonna look back. Oh, Arena, Mr. Park? I don't know, they're looking a little tired already. Guys, this right here, though, I agree with you 100%. This will wipe you out, wipes me out. Just to do everything to be done. Can be done though, she's gonna send out beautiful notes. She loves to use the different colors and so forth. But doing rational functions takes, so it looks like it to me, an hour and a half to do 2 problems. Now, I'm wondering in chapter 4, when you guys get back from the break, which is a relief. And I'll come back to the remaining rational functions later on. Guys, go ahead and take your break. I'll see you at 15 till